Thank you so much. Welcome, everyone. So great to talk to you today. Mark, I'm actually going to turn right to you, and I'm going to start with what is certainly the gorilla in the room, and that is NVIDIA. Is there a way to dethrone NVIDIA, or in AMD's case, to at least close the gap?
Well, great question. And you know, Sharon, we've been competing with NVIDIA for decades because we've been in the graphics business through our acquisition of ATI. But when you look at the story of AMD, it's twofold. We started with focusing on CPUs, grow the revenue of the company. But what people don't realize is under the cover, we were working on heterogeneous computing and our open software stack, ROCm underneath. Now we are a competitor. We went from almost zero in 2023 of AI revenue to $5 billion projected this year. And so we're strong, actually leadership and data center GPU inferencing, and watch out on training. We're bringing the competition right to NVIDIA in training. The market needs competition, and that's what we're focused on.
Andrew and Sandra, so this is a complex landscape, and the competitive landscape is very nuanced when it comes to training and inference and all sorts of areas of the semiconductor industry. I want to ask you also, Andrew, about the competitive landscape from other startups, hyperscalers, and then Sandra, I'd like to hear about the competitive space on your end. Andrew?
Well, I think there's so many players in the market because the market's so darn big. Right, I think we have NVIDIA, we have AMD, and under Lisa and Mark's leadership doing great things. But you also have the hyperscalers seeing opportunity explode and wanting to do their own chips. You have a collection of startups, I'd like to think led by Cerebras, doing pioneering work. I think when you have this sort of activity, it's because you have an explosion of demand. And we're seeing it on the training side, we're seeing it on the inferencing side, and I think, truth be told, none of us can keep up.
It's kind of a Hunger Games out there.
It is,
that's what I hear.
A little bit.
Sandra, what about you at Altera?
Well, I'll start by saying that it is still early days of AI, and so there's so much innovation ahead of us, and it really isn't, how do you take on NVIDIA? It is how you have the best device for the workload that you're driving. And to Andrew's point, the workloads, the segments, the customers are so diverse that it is not a one-size-fits-all. And that's why you have CPUs and GPUs and accelerators that are bespoke and dedicated to AI. And even in my field programmable gate arrays, FPGAs, which are highly customizable, highly flexible, and highly valued in markets that are changing very dynamically, very quickly, like AI, like cybersecurity, certainly wireless standards, and those types of applications lend themselves to devices that are highly programmable and flexible to the workload. So I think there's a lot of opportunity. There's still early days, lots of innovation to come. And Mark and I were commenting before the session of the fact that competition is good. It makes you sharper, makes you more focused, and it certainly addresses the very, very broad customer requirements that are out there.
But Mark, what would you say, NVIDIA is not just any competitor. I had an analyst tell me that NVIDIA doesn't have any real predators in the wild. do you see that? Or do you see that competition is growing and that there's really a place to close the gap and find that opening, even more so for your company?
Yeah, I don't believe that whatsoever. That's why we're making the gains that we are. We're actually getting tremendous pull. You think about the placements we have with first-party applications in several hyperscalers with our GPUs. You saw Microsoft announce that they're in production with our MI300 GPU. Meta announced that they're running the Llama 3.1 470 billion parameter model. All the inferencing's running in production on AMD. And why is that? Because the market demands competition. And so we're getting a tremendous pull. We're not seeing a moat. Again, we're a GPU just like NVIDIA, so if code was written low-level CUDA, it can be in a straightforward way ported over. And people are moving to Triton and JAX and other higher-level vendor unspecific coding, and that's going to really open up competition as well.
Nobody wants to be locked into a particular hardware's
That's right.
Code.
Yeah, and I think this point on abstraction away from the underlying logic device is really powerful because most data scientists, most subject matter experts, most of the programmers are really not at those low levels. They're highly abstracted and they're just trying to get their workload deployed in the market at scale as quickly as possible. So very much this is not so much what is the actual, is it a GPU, is it a CPU, is it an AI accelerator, an FPGA? It's very much what is the system and the platform, and then what is the software that enables that so that developers can actually be productive very, very quickly.
Right. Well, this is the CHIPS panel at Brainstorm AI, so I know folks will have questions out there, and I'm going to come in just a couple minutes, so think it over. But right now, Andrew, so IPO. When I last wrote about, Cerebras and the potential IPO back in the beginning of October, where are things at now? Can you share?
I cannot share, so this is going to be a very boring panel from
dear.
here on. I can share nothing. But I would like to.
Mark wants to know.
Mark's an investor. Mark would like to know. I would say the following. Mark's GPUs are running faster than NVIDIA's. Our accelerators are running in many instances 75 times faster than NVIDIA's, and you can go to artificial analysis and check daily scores on their benchmarks. I think others, not just ours, others are running much faster as well. I think what Mark said is sort of fundamental, and it's not just that it's better for us that there's competition. I think it's better for you that there's competition. It means that the AI in your applications will run faster and cost less. And there aren't any markets where that proposition hasn't held. And so I think that's the fundamental thing. It's good for everybody if there's competition in AI, if there's innovation at the underlying levels. And I think that's, we're seeing that across the board.
This battle for inference speed is really interesting. There's like every week there seems like to be a new announcement, including from Cerebras. Do you see that as a way to really diversify your customer base going forward?
I think in 2017, OpenAI published a paper which sort of predicted the vast rise in training compute, and they called it the scaling laws. And then in September, they published a paper that found some of the same rules apply in inference, which means we're going to use a huge amount of inference compute in the years ahead, an absurd amount of inference compute. And we're going to do inference not once, but many times on the same query. And if you can run fast, you can deliver higher quality results in less time. And so speed will be fundamental to the delivery of high quality inference in a reasonable amount of time. And so I think that's why you're seeing this extraordinary race to be fast at inference.
A need for speed.
Need for speed. I think when I look out in the room, I can see that there's a little bit of gray hair here. And you remember before we had broadband and trying to use the internet before broadband was a disaster. And once we got broadband, all of a sudden you had new applications, you had streaming, you had all these things that were fun. And the engagement was high, and I think that's what's happening right now with AI, is that as you get faster, you move into the sort of the broadband era of AI inference, and things are engaging, they're responsive, and they're higher quality.
Sandra, obviously last week's news about Intel's CEO resigning was big, it was surprising, and of course a lot of people want to know what that means for Altera. I was wondering if you could share your thoughts on the future of Altera. Does it change your strategy in any way?
Yeah, our plan has been to go out for an equity stake. Intel is still planning to sell an equity stake in Altera, and we're in the middle of that process now with a lot of great interest, which is encouraging. And we still plan for an IPO in 2026. That's been the plan, and it really hasn't changed. And the news from last week was, sad on so many levels. But what I try to keep the company and the employees focused on is the things that we control, because we really don't control any of that. We control our commitments to customers, our product execution, our innovation, and that's what we're focused on. But the plan is the plan, and it has not changed.
Okay. I'd love to see if there are any questions here. Okay, yes. Do we have a mic person? Here we are. And just state your name and your affiliation. Thank you.
Yeah, hi. Pankaj Kedia, ex-Intel and Qualcomm. Andrew, just clarification, is Cerebras training or inference or both?
We do both.
Both. So my question is, maybe Mark and Sandra, AMD is on both sides of the wire, right? Data center and inference. Same thing as ex-Intel or Intel. Fundamentally, what advantage does that give an AMD, an Intel, and maybe Cerebras? Because when we think about NVIDIA, we think primarily about the data center. On the edge, they have graphics, but they don't have the full SoC, if you would, right? So fundamentally, how does that better position the three companies end to end?
Yeah, I can start. I think it's important to even think about the analogy that Andrew just stated. It was back to the internet and thinking when all the applications came out. And it went sort of vertical sector by vertical sector, and it changed. Its technology needs were different. That's what you're going to see as AI explodes. So of course there's training and there's different requirements for these, these foundational large language models. Today they're all on a GPU, and as I said earlier, we're now bringing competition there. But there's an advantage there when you want to run inference on those largest foundational models, because now as a GPU you match up with the math constructs and how the transformers were deployed, et cetera. So there's an ease and a facility of getting a higher performance on those foundational models. But inferencing now will span out across sectors. It'll be different in unique enterprise. It'll be different on the edge. That's why we're very focused on diversity in our portfolio. We've enabled AI across that portfolio, our entire portfolio, our CPUs, you look at our AI PCs, and the AI enablement across the CPU, GPU, and neural net engines, and all the way through our embedded and FPGA roadmap. So I think it's the advantage is what we're going to do is simply ease customer adoption, a unified software stack on top, and just ease the optimization. But it's going to be wild. It is early days, and I think yet to come is the myriad of inference applications across that strata.
Yeah, and I would just add that back to the right device for the right workload, and that typically is a decision point around power, performance area, and cost. And when you look at the tremendous cost that is required to build these foundational models, it probably leads you to certain types of devices that can really do that workload, and back to kind of the point you were making on training. But when you look at the inference workloads, and particularly data wants to compute, it wants to compute near where it's created or where it's deployed. And typically that is happening much more broadly at the edge, what we call edge computing. And those workloads really have finite power, performance, area requirements, whether you're in a manufacturing location, an industrial robotics type of implementation, on autonomous vehicle. You really don't have the luxury of hundreds of watts. I mean, in many cases, it's single-digit watts, if not lower. And so that's why, back to, it is not a one-size-fits-all, and much of the growth and opportunity is happening at the edge, again, where the data is created and consumed. And that's why you see a diversity of devices for running those workloads, whether it's a CPU, GPU, FPGA, and AI accelerator.
Just one small thing. I think it's a mistake to think that compute at the edge comes at the expense of the data center. That's just not been the experience over the last 30 years. As we got more compute in our cell phones, data center demand for compute didn't go down, it went up. All right, it went in exactly the opposite directions. As we got more compute in our cars, data center demand didn't go up, it went down. As we added more compute in our homes through Alexa and all sorts of devices, data center demand didn't go down, it went up. As we get inference at the edge, data center demand is going to go up. Models have to be trained. The limitations exactly described here of limitations of power delivery, running on a battery, the amount of storage and the memory capacity of the device that lives at the edge mean that there's going to be good work there, but some work's going to go back to the data center. And so I think it's always framed as either or. And in fact, the rise of the edge drives continued growth in the data center.
Well, speaking of across the portfolio, critics say that GPUs are a bit of an environmental disaster. AI chips and generative AI generally, whether it's the hundreds of thousands of GPUs that train these large foundation models, or the kind of amount of compute that it takes for inference. I've heard numbers like an OpenAI query takes 10 times as much compute as a Google search query. What do you say about that? How do you ensure that your technology does not do that, does not contribute to that? Does the speed of inference help with that? What else can help, and what are you doing, Andrew?
We have a wafer scale solution, and that means we built the biggest chip in the history of the compute industry, and we keep data on the chip where it's moved more quickly and uses less power. So we use order a third the power of a GPU for a similar calculation. But even at a third, our industry is consuming a lot of power. And I mean, there's no way around that. And I think there are a couple things we have to do. One is we have to work at the algorithmic level to improve the use of the compute, right? Many machines multiply by 0. It's called sparsity. This is a waste. You don't need to do that. You don't need to spend the time and effort and power to do that, because you know the result before you do the calculation. There are a whole set of algorithmic techniques that are being explored right now in the industry to make the computation that pulls the power more efficient. All right, and then we got to get more benefit from our AI. All right, and as it moves to have applications, whether it be in the identification of drugs or in other things, then it's the question isn't, oh look, we're just pulling a lot of power, but how did it compare to other choices we would have made in the development of this drug, or to find this answer? And so I think those are some things that come to my mind.
I couldn't agree more. In fact, I'll go further to say that to have energy efficient AI computing, it's fundamentally changed the way that we solve the problem. I call it holistic design. We can't anymore, any one of us, think about just one element of that computation chip that we're developing. Andrew went to a wafer scale integration. We were the first to adopt on packaging. We do both horizontal 2.5D connectivity. Our MI300 also has that, and 3D stacking. Why? Because there's less energy as you're solving the problem and you're calculating on the models. But it is more than that. It is developing new algorithms, new math approximations, and it goes right up through the rack level integration. It's why if you look at our acquisitions, including in progress CT systems, we're not going to get in the system business, but we need to optimize for power consumption all the way through the generation of AI racks and clusters. The game has changed.
Yeah, and I think that back to the adage of necessity is the mother of invention. Clearly, we will not have enough power to run all of the AI that the world wants to run on current course and speed. And so you are going to see a lot more focus and a lot more innovation in battery technology, in nuclear technology and deployments, and trying to focus on green energy as part of that equation. And when you deploy AI, we know we need compute, we need data, and we need algorithms. And I will underscore Andrew's point that compute will run its course in terms of Moore's law or slowing down Moore's law, but you will get advancements there. Data, there's so much data being created, and it just continues to grow exponentially over time, particularly exploding at the edge. But the real breakthroughs are going to come in both innovation from a power perspective in terms of either battery or nuclear technology, and from algorithms, which can give you 10x, 100x, 1000x the type of breakthrough capability to get more out of that same platform of compute and data.
Any other questions from the audience about any of this? I see a hand back there coming over.
Hi, Alexei Orezkovic with Fortune. I'm curious about the U.S. CHIPS Act, and from what I understand, it's a lot more expensive to manufacture when these fabs come online in the U.S. versus Taiwan, and so I was curious how that impacts your own plans for manufacturing leading edge stuff.
Yeah, well, maybe I'll just start out by saying that a globally diverse a resilient supply chain is good for everyone. And I think we all learned that very painful lesson during the pandemic and a lot of the supply constraints that ensued. And the CHIPS Act is really just one step of, I think, what will be required to be many steps moving forward to level the playing field, because there are other parts of the world where governments support and subsidize through, whether it's R&D credits, whether it's through tax policy, whether it's just subsidies for companies to remain on that leading edge. But I'll just go back to the fact that competition is good. Competition drives more innovation. Customers like choice. And the semiconductor industry is so crucially important to the US and the West that the CHIPS Act, not just in the US, but in Europe as well, I believe that there's a lot of energy and conviction around continuing with those types of policies to ensure that we can stay on that leading edge of innovation and that customers have choice from the perspective of where they actually fabricate their semiconductors.
I'll add on, the geographic diversity is certainly key. We're number 1 or 2 customer of TSMC in Arizona. The yields are coming out equal to what it was in Taiwan. And so your question, is it more costly? That, if you can get the yields equivalent, the cost amortizes over time. And so it is going to be more, but that, in the blend of customer buy, I don't think that's going to be a major factor, again, if you can get the yields up, which TSMC has achieved. And then more broadly, I'm a member of the Industry Advisory Council with Department of Commerce, and I know myself and peers across the industry are all focused to generate more semiconductor design here. And that's where the National Semiconductor Technology Center, which is now being amped up and giving grants, driving more chip development, packaging development, really spawning a rebirth of semiconductor development research, both here and with our allies.
Just one final thing. When you guys think about fabs, these are about the greatest things we make as humans. These are $30 billion factories that have 5-year, 6-year lives. They're extraordinary things. And that there should not be cutting-edge fabs in the US was just bad industrial policy. It's just bad industrial policy. And that we can now, through the work of the various government acts, bring these fabs to the US improves all our industry.
Well, thank you so much. We are out of time. This was great. Thank you so much to Sandra, Mark, and Andrew.